Hey, how's it going? So in this video, I'm going to be going over and showing you how to do the basics on the Pokemon 1 battle game. So, in this video, we're only going to be doing the basics of the assignment. So this part right here. Tracking the HP and the energy of each Pokemon, each ability having a different amount of energy. Damage is different for each, but within some range. Uh, Enemy Pokemon will attack with some random ability. Continue until one of them has 0 hit points or less, and allow the game to be played over. So, one thing they need to know before you watch the rest of this video is that you're going to need to do extra stuff in order to get as many marks as you would have if you didn't watch this video. The reason why is because since you're following this tutorial, you're going to not be showing as much skill as if you did this by yourself. So, if you follow this tutorial and you just copy the code that I'm about to write, that would give you a developing one. Okay? If you write this code that we're going to do together, and then afterwards you comment it, I'm not going to be putting in any commenting, but if you put in commenting showing what everything does, then you'll get a developing 2. To get higher than that, you'll need to do this bonus stuff. I'll be writing the code so that adding this stuff isn't that much difficult. It's going to be quite extendable. That will get you into the proficient range. In order to get into the exemplary range, you'll need to go beyond just doing this and add something new of your own choice. Okay, so it can be whatever you want, but it needs to show really good skill to show that even though you watch this video, you still are an exemplary student. Okay, so keep that in mind right now and make a choice. Do you want to watch this video? Those are going to be the rules that you need to follow. If you want to try to do this on your own, go ahead. And then completing this exemplary challenge will be the only thing you'll need to do an exemplary, but you'll need to create everything by yourself. And I will know if you watch this video because when you're trying to do all this stuff, if you watch this video, you'll have a very hard time trying to come up with an alternative way of doing all this stuff than the way that I show you. Once you see how something is done, it can be very difficult to think of a different way to do it. And that's how I will know whether or not you watch this video. Okay? So, if you keep on watching, those are the rules. So, let's get started. So, we're not going to give them any choice. And the first thing we're going to do is we're just going to assign all the variables that we need right away. So I'm going to give a little bit of room at the beginning because there's going to be something at the top that we need to put in order to get the game to play again. And let's start making our variables. So we need something that's going to keep track of the hit points. So let's do that, the hit points and the energy. And make sure that you're naming all of your variables descriptively. So I'm going to have a variable called player health. And I'm going to set it so that they start off with 100 hit points. We'll do the same thing for the opponent. I'm going to say the opponent is the enemy. Set that to 100 as well. Okay? So note that I'm not making anything specific about the types of Pokemon that they're using. Instead, I am abstracting to just the player and their opponent. I don't care what Pokemon they are. All matters is that there's those two players. Then we're going to do, likewise, we're doing player energy. I'm not going to start them off with 10 energy. I'm going to actually start them off with like 3 energy. But I'm going to make it so they can't go any higher than 10 energy. And likewise, I'm going to do the same thing for the enemy energy. And they also start off with 3 energy. You can play around with this a little bit. Once everything is done, then it's just a matter of game balancing to choose the values that you think makes the game the funnest. That's what I'm going to start off with though. Next, we need to give them what Pokemon they're going to play with. They don't get to make a choice because we're only doing the basics. And I'm not going to name the variable after what Pokemon they get. Once again, I'm going to abstract, which means take away all the stuff that's not relevant and just focus on the key things that are important. And so I'm going to have the player Pokemon be a variable, which is going to keep a string containing the name of the Pokemon. And I'm going to say player gets to play with Pikachu. Because, you know, it's kind of the default Pokemon that everyone knows. And then the opponent is going to be the greatest Pokemon that's ever Pokemon. I'm speaking, of course, of Magikarp. So those are going to be our two Pokemon that they're going to get to play around with. Now that we created those two Pokemon, what we're going to do is we're going to create the different moves that they are going to use. And so each Pokemon is going to have 3 moves. 2 of them are going to be attacks, and 1 of them is going to be kind of a utility move. So they're both going to have what I'm going to call an attack move, which is going to be their basic move, and then going to be a special move that is going to be higher damage but higher energy. And they both get one of these kind of attacks. The only difference is going to be what they're called. So I'm going to have a new variable. I'm going to call it player attack. This will be the name of Pikachu's regular attack. And I'm going to say it's going to be called tackle. Likewise, I'm going to do the same thing for the enemy. They also get an attack. And I'm going to call it Splash. Because that's one of Magikarp's moves, I'm pretty sure. Then, I need to decide what kind of damage this thing is going to do. It says in it that we want to make it so that it does some random damage within a particular range. We kind of already know how to make random numbers that go from like 1 to something, but now we want something that goes like from 10 to 15. So that's what I'm going to have the regular attack do. It's going to do between 10 and 15 damage. And so I am just going to store what's the minimum and maximum damage in variables so that we can use that when we're actually calculating the damage. So I'm going to say let the attack minimum, so min for minimum, is going to be 10 damage. And we're going to let the attack maximum be 15. So for both of the Pokemon, it's going to do between 10 and 15 damage. Finally, we are going to give it some sort of energy cost. So we're going to say the attack energy cost is going to use 2 energy. So pretty low energy attack. They can just spam it if they want. Now we're going to do the same thing. We're going to create 5 more variables for their special attack. So we need to, once again, make a variable for the name. So I'm going to have player, not play, and give it a name. And I'm going to call it Thunderbolt for Pikachu. That's their special attack. And the opponent will also get a special attack. And I'm going to call it, no, not minus. I'm going to call it Water Gun, because I think that's one of the special attacks that Magikarp gets as well. So we got those. And once again, we're going to give it a minimum, a maximum, and an energy cost. So we have the special minimum damage. Let's say it's going to do between 15 and 25 damage. So more than the regular attack. So like that. That the special max is going to be 25 damage. And then let the special energy cost. This is going to use more energy because it's a higher energy attack. Not going to be able to use it all the time. We'll make it use 4 energy. Okay. So there we go. We made our 2 special attacks that they're going to use. The last one is going to be just a rest. We don't actually need to make any variables for it. We could if we wanted, but I'm going to not do that. I'm going to make 3 more variables that are going to be useful for everything else, and they don't necessarily need to be given values right now. One, I'm going to make a variable called player turn. This is going to be a Boolean value that will tell me whether or not it's the player's turn or their opponent's turn, so I know what I need to be doing. And we're going to start off with it being true. So player gets to go first. Next, a couple other variables that I'm going to want to use. I'm going to have one called move, which I'm going to use in order to determine what move they're going to use or what attack. Doesn't need to be given a value right now because they haven't chosen anything. Also, I'm going to have a variable called damage that I'm going to use in order to calculate the damage that the player does or their opponent does. Doesn't need to be special for either the player or the opponent because I'm only going to be using it for a small chunk of code so they can both reuse that same variable. And that's it. Those are pretty much all the variables that we need. So, oops, sorry, didn't mean to shrink that down. Trying to shrink my other page down. There we go. So, first thing we're going to want to do is we should introduce the game. So, the way that we print stuff out is with console log. And let's say, do a little message, say, welcome to Pokemon Battle. And we'll say, I don't know, try to do your best to defeat your opponent. Little introduction so that they know what's going on. And let's do an end of line character right at the end there so that we got a little bit of space for the next thing that we print out. Remember that this -n, the end of line character, what it does is the same thing as like hitting enter on a word processor like Word or Google Docs or whatever. So, introduce the game. Now we need to get into the battle. The battle, we're going to keep on continuing. They're going to go back and forth having different turns. And we only want to stop when one of them gets defeated. So that sounds like a job for a while loop. We want to keep on doing this until something happens. And that something is, we want it to stop as soon as one of them falls below 0. But we're not going to say when do we want this to stop. We're going to give a condition of when do we want this to continue going. And we want this to continue as long as the player health is greater than 0. And we also want the opponent health to be greater than 0. So while both of them have more than 1 hit point, we're going to keep on playing. And so this is going to be our main game loop right here. And then what we need to do is we need to check, well, okay, this is our loop. We're going to see whose turn it is. And depending on whose turn it is, we're going to have some code that implements their turn. So I'm going to say if, I'm going to check whose turn it is, and I'm going to use that player turn variable that we made to tell me whose turn it is. So if it's the player's turn, we're going to do this. There's going to be a whole bunch of code in here. I could just have an else here, because if it's not the player's turn, it's the opponent. But in order to help make things a little bit more readable, I'm going to actually make it an else if. And I'm going to say if it's not the player's turn. A little bit redundant. It's not strictly needed for me to give you this condition, but it does help with the readability so that when we're looking at the code, we understand what each section is doing. So this will be the player's turn, this will be the opponent's turn. So what do we need to do when it's the player's turn? Well, I want to give them a little bit of energy regen because we only start them off with 3 energy. And if they run out of energy, then they kind of just can't play. So I'm going to give them a little bit of energy right at the beginning of their turn. I'm going to say player energy. I'm going to add 2 energy to it. So a little bit of energy. It's going to be enough for them to use a regular attack every turn. But I also don't want them to be able to go above 10 energy. Like in most games, there's a limit of how much of a resource you can have. So how do I make sure that I don't go above 10 energy? You think, well, we could use an if statement for this. And you're right, we can. But there is something else that we can do that will be a little bit easier, and I haven't shown you guys. What we can do is we can set player energy to equal, and we're going to use something from the math module. We're going to use the math.min function. And what this does is we're going to give it a whole bunch of arguments inside of these brackets, and it's going to return whatever is the smallest of them. And we want to have the player energy to be the smallest of either whatever the player energy is, but if it goes above 10, we want to give 10 instead. And this will mean that player energy can't be more than 10. This is like the maximum energy right there. Okay? So that will make it so that it can't go above 10 energy. Alright, that's taken care of. Now that we've given them energy, we need to kind of tell them what the state of the game is so that they can make a good choice about what move they want to use. If you don't know how many hit points you have, or how much energy you have, or how many hit points the opponent has, you're not going to know what to do. So that's what we're going to do first, is we're going to print out some information that tells them what the state of the game is. So we're going to do console log, and I'm going to start off with telling them how much, everything about their Pokemon. Don't want to use that. I'm going to be using ticks like that. Remember, when we use those ticks, that means we're going to do some string formatting. That means I can insert variables. I'm going to say your, and I could say your Pikachu, but I want to use that variable that I created. And instead I'm going to say your player Pokemon, which is Pikachu, and then has, and then I'm going to just make end of line character, and I'm going to list out their stats right below it. So after that, I'm going to print out their hit points or health. Okay, hit points or health there, kind of up to you. And then the second thing I need to do, so I'll make a new line, and then I'm going to say they got player energy's worth of energy. Okay? Now I'm going to do the same thing. I could continue on with that console log, but it kind of makes sense to put it on a new line for all the opponent. And I'm going to do exactly the same thing. So I'm going to say the opponent, and then I'm going to name the opponent Pokemon, which is Magikarp. So I could put Magikarp in there, but I'm making it use variables so that if I wanted to go and have them choose what Pokemon they wanted to use, it's already set up to do that. So I'm going to say enemy Pokemon has, and then once again, I'm going to list out their hit points and energy. So start a new line, and say the enemy health, hit points, and then start another new line, and list out how much energy they have. The enemy energy. And there we go. So those two lines print out what the current status of the battle is. Next thing I want to do is I want to ask them, okay, that's the current state of the game, what you're going to do. So I'm going to list out what are their options, what are their moves that they can have. What I want to do for this is I want them to enter in a number to select what it is, because it makes it a lot easier for them. They don't have to write out the whole name. They might spell it wrong. They might use capitals when I'm not checking for capitals. Numbers just kind of make things a whole lot easier. So I'm going to now print out what the different moves are. Say I want you to tell me what move you're going to use. So what move do you want to use? And then I'm going to list out the different moves as well as what number they should press in order to use that move. So start a new line. I'm going to say enter 1 if they want to use. And actually I want to be using ticks here as well. I made a mistake there, because I need to use those variables again, just like how I did here. So I need to use those ticks. And I'm going to say player attack. I believe that's tackle. So I'm going to say press 1 to use tackle. Then I'm going to do a next line and enter 2 to use the player special attack, like this. And finally, I'm going to have them enter 3 to just rest. And that's going to be used for them to get some extra energy in case if they're running low. Okay, so I told them what all the options are. Now I need to get some input from the users so I can see what move they want to use. And remember, in this assignment, we need to do input verification to make sure that they're giving us a good input. So there'll be 2 things we need to check for. First, did they enter a number? If they didn't enter a number, we need to stop them and have them enter a number. And we need to give them a relevant error message so they know what they did wrong. Second, we need to make sure that they enter in a 1, 2, or 3. Okay? So it's a number, but it needs to be a number that is one of those numbers. So we're going to do a while loop. And I'm going to live dangerously and use a while true here. It's often good to avoid while trues, but there are some good cases to use them. I'm going to use one here. And so first thing I'm going to do in this while true, well, I'm going to use that move variable that we created. Remember, this move variable is being used in order to check what move they want to use, so this should be a 1, 2, or 3. And I am going to be looking for a number, which means I want to convert whatever they enter into a number. And then I'm going to be doing a prompt like this. Oh. Asking them to enter in their choice. And I'm going to say, just select your move. That'll be the message I show them on the console, prompting them to enter something. There we go. We've gotten their move and turned it into a number. Now we need to do the verification part of input verification. That means checking for 2 things. Checking if they entered a number, and was that number between 1, 2, or 3. So first check, was that a number? For this, we're going to use the is not a number function. And we're going to check if move is not a number. The reason why this works is if they try to enter something that is not a number, and we try to convert it into a number using the number function, this will become not a number. And so we're checking if it is not a number. That would indicate that they entered something that's not a number. If they did, then we need to give an error message. So I'm going to do console.log, and I'm just going to say, that's not a number, an error message. So they know what they did wrong, and when I prompt them to do something again to enter the move, they know what they need to fix. Alright, that's done. Next. Okay, we got this far, we know it's at least a number. Now, we could do this in 2 different ways. We could check if it is a 1, a 2, or a 3, and that would work. I'm going to do things a little bit differently. Instead, I'm going to check if it is less than 1 or greater than 3. Because we typically want to check for the bad inputs so that we can give a relevant error message rather than the good ones. This method does have a weakness. It won't be a very big weakness, but a slight weakness. And that is they could enter in something that is a decimal number. Like if they entered in 1.5, this would not catch it. Maybe you might want to do something that will fix that, but I'm going to assume that they're not going to do something like that. So I'm going to say just else if the move that they entered is less than 1, or, and there's our or sign, move is greater than 3. And if it is, once again, we need to give an error message. So console.log, that's not 1, 2, or 3. So different error message because it's a different error. Finally, I'm going to have an else. And this is meaning, okay, I didn't find any errors in it. And that means we can exit this loop. And so this is, well, this while true loop would go on forever. If we hit this break, that means that we can exit the loop, and we only hit this break if they entered a good input. So now we know that move past this point will be a 1, 2, or 3, or maybe a decimal, but we're ignoring that. Okay, now that we've gone what they wanted to do, now we need to have that move happen. So we need to check what move they entered, and based off of what move they entered, we need to do different things. Here we could once again do an if, else, kind of like this. But since we're just really checking what the value of move is, it would actually be better to use a switch case here. Switch cases are really good for when you just want to check what the value of a variable is and do different things based on it. So that's what I'm going to do. I'm going to use a switch case. So I'm going to say switch. And what is the variable that I want to check the value of? Well, it's that move that you just entered. So that's what I'm looking for. And now I need to do the cases. So what if they entered in 1? Does password? I don't think it does. So we got case 1, where they entered a 1, which remember is the regular attack. We got case 2, which is a special attack. And finally we got case 3, which is the rest. So case 1, what do we want to do if they entered to do the regular attack? First thing we need to do is we need to calculate the damage that they're going to do. So notice that I am calculating the damage here, and I didn't calculate it way at the top. All I did was I set what the minimum and maximum values were and didn't actually calculate damage. The reason why I'm doing it here is because if I calculated this damage for every move at the beginning of the code, then it would be stuck like that. They would do the same damage for that attack every time. It would be randomized every time you play the game, but every time you use that attack in that same game, it would do the same damage. I don't want that. I want it to do different damage every time, so I'm going to calculate this damage only when they are using that attack. Now, how do we calculate a damage for that range that we wanted, that minimum and maximum? And this is going to be how we do it. We're going to do it in 2 parts. We're going to calculate the random part, which is going to be the part that is between 10, well, it's actually going to be between 0 and 5. And then we're going to have another one that we're just going to add the minimum to it. So, first thing we're going to do is we're going to need to round this thing down. Then we're going to generate that random number and multiply it by the range that we want. So we want between 0 and 15. Minimum is 0, and maximum is 15. In order to do that, or sorry, the minimum was 10, wasn't it? We're going to use this equation. And so, believe it or not, math is actually pretty useful outside of a math class. This is one of those cases. We want to multiply it by the attack maximum minus the attack minimum. So that's 15 minus 10 gives us 5. But if we round down, that's going to give me a number between 0 and 4. I don't want that. I want a number that's between 0 and 5. So to get that 0 and 5, I'm then going to add 1. Alright? So this will give me a 6, which we then round down. So a number between 0 and 6, which we then round down using Math4 to give me a number between 0 and 5. That's an integer. Great. So we got a number between 0 and 5. How do we turn that into a number that is between 10 and 15? Well, we're just going to add the attack minimum after we do that. So number that's between 0 and 6 plus 10, or 0 and 5 plus 10, now gives me a number that's between 10 and 15. There we go. And so that's how I can use these minimum and maximums to generate a number that is within that range. Good. Now, what do I need to do with that damage? Well, I need to remove that from the opponent's hit points. So I'm going to take the enemy health and I'm going to subtract from it that damage that I just calculated. That's it. There we go. Damage done. But this is not a free attack. It takes 2 energy. You say, well, Mr. Clark, don't I need to check if they have enough energy before they use this attack? And often you do, but I made a design choice here that means I don't actually have to. The design choice is right here. The attack uses 2 energy, but at the start of every turn I give them 2 energy. So I know that they have to have at least 2 energy at the start of every turn, so they're always going to be able to use this attack. So I don't actually have to check if they have enough energy. I've made the game so they are guaranteed to have enough energy. If I did not have this choice, if I set this to a 1, then, or if I had it so that at least the energy that it cost was more than they regen every turn, I would need to check that. So if you want to change values, keep that in mind. But for my choices, I don't have to do that. So I'm just going to now take the player energy and I'm going to subtract from that the attack energy cost that we created. Remember, energy cost right here. Cost 2 energy. Finally, so I've taken the calculated damage, removed it from the opponent's health, removed the energy cost from my energy. Now I need to give some sort of message to the player so they know what happened. So go console.log. And once again, I'm going to use those ticks because I want to be able to put some variables into this. And I'm going to give a message about what happened. So I'm going to say that the player Pokemon used the player attack. So that's a message saying what attack that they used. I'm going to make a new line, and right underneath that, I'm going to say how much damage they did to their opponent. I'm going to say the opponent, and then the name of that Pokemon, which is the enemy Pokemon, took, and then using my damage variable to tell them how much damage they did. They did that much damage. There you go. And that's really it. Last thing I need to do is whenever we're using a switch case like this, after every case, we need to do a break. The reason why is a little used feature I use in quotations, it's not actually super useful, is that switch case has something called fall through. And so if I didn't have this break, it would do all of this, and then it would move on to case 2 and do all of that. And then move on to case 3 and do all of that. I don't want it to do that. I want it to, after it's finished case 1, I want it to stop and then go on to the next part of the code, not continuing on with the switch case. So that's what this break does. It just stops it from going on to the next cases and doing that code as well. Okay. Now, case 2. That's when they use a special attack. The special attack uses 4 energy, not 2. So I don't know that they're always going to have that amount of energy, which means I need to check first before I do anything else. So I'm going to say if the player energy is greater than or equal to the special energy cost. So do they have enough energy to use this special attack? Then we're going to do the same stuff that we did before. We're going to calculate the damage. It's going to be basically exactly the same as this. In fact, I'm going to copy all of this stuff, and I'm just going to change it so that it works for what we want to do. Notice that this stuff should be tabbed over So I can just select those 3 lines, I can hit tab, and now they're all tabbed over appropriately. But this is not the attack anymore, so wherever I see attack, I'm going to replace it with the special. So the special max minus the special min, special plus the special minimum. That calculates the damage using our special attack minimum and maximum. It's exactly the same structure as above, just uses those different variables. Next, we remove that damage that we just calculated from the enemy health. That part stays the same. Here, we're removing the energy, but we don't want to remove the attack energy. We want to remove the special attack energy. So change that one as well. And then down here, when I'm giving the message about what happened, they didn't use the player attack. Instead, they used the player special attack. And that's it. That's the only thing that's really different between these two, is rather than using my attack variables, I'm using the special variables. Okay? So that part's all good. But now, what if they didn't have enough energy? That else, here, this only happens if they have enough energy. What if they don't have enough energy? Well, as a game designer, I'm making this game, I get to make a choice what happens. I'm going to say they just fail. They don't get to use their attack, and they lose their turn. So I'm just giving a message here. And I'm going to say that they tried to use that attack, but they didn't have enough energy. Too bad. So, I'm going to say that the player Pokemon tried to use that attack, the player special attack, but didn't have enough energy. They tried, but they couldn't do it. Oh well. Lose your turn. And so that's the end of that part. And remember, at the very end, we need to put a break. So that's now the special attack done. Case 3. This is going to be our sort of special utility action. It doesn't actually do any damage. All it's going to do is give the player some extra energy so that they can use this special attack next time. And so I'm going to take that player energy, but rather than subtract from it, I'm going to add to it. And you know what? Let's give them 3 energy if they use this. So they get the 2 energy at the beginning, they'll get another 3 energy, so if they rest, they get 5 extra energy that turn. Pretty good. But I don't want them to be able to go above 10, so just like before, I'm going to then enforce that the maximum is 10 by using that minimum function. So I'm going to take that player energy, set it equal to math.the minimum of whatever it currently is, or 10. Whatever is the smaller of the two, that's what energy becomes. Finally, I need to give some sort of message saying what happened. So, console log, and if they use this, give a message saying that, use text again, the player Pokemon, oh, it needs to be capitalized, rested and gained 3 energy. If you wanted, you could set that to a variable as well, and then you would use the variable here, but I'm just going to hard code it and say that no matter what, it's always going to be 3 energy. And that's it. That's really all there is to the player's turn. We give them some energy. We tell them what the state of the game is. We ask them what move they want to do and make sure that they enter in a valid input. Then based off of what they chose to do, we pick one of these cases and do what is needed for that attack. Calculate the damage, remove it from their opponent's health, remove the energy cost from our energy, and give a message about what happened. So, Now we need to do the opponent's turn, because the players now got all their turn figured out. And the player turn is going to be, or opponent's turn is going to be very similar to what we already did for the player's turn. We're going to give them some energy, make sure they don't go above 10, figure out what move they're going to do, and then based off of what they chose, implement it. So let's give them that energy right at the beginning. We don't need to give any message here because, well, the computer player doesn't need any messages to know what's going on. So I'm just going to say the enemy energy increases by 2. And then I'm going to make sure that it doesn't go above 10. So using that math.min function to ensure it doesn't go above that. Not like that. So enemy energy or 10, whatever the smallest of the two is. There's also a max function if you ever find a need or use for it, in which will give you the bigger of the two. And it doesn't need to even be 2. You could put in multiple values in here, and it'll just give you what the minimum or maximum of all of those are. But we only need to check for the 2 things. Alright, so give them the energy, make sure they didn't go above 10. Next, we need to choose what move they're going to do, and they're going to just choose randomly. So, we're going to reuse that move variable, and we're going to generate a number that's a 1, 2, or 3. We already seen how to do that before. I'm going to use the math.ceiling function, so I round up, because I don't want a 0, I want a 1, 2, or 3. I'm going to generate a random number between 0 and 1, like that. I'm going to then multiply it by 3, so I get a random number between 0 and 3, and then the math.ceiling is going to round that up to a 1, a 2, or a 3. Done. If you really wanted, you can have it so that it does different attacks with different probabilities. That could be something extra that you include, but I'm not going to do it here. Every different ability is going to have an equal chance of happening. Now, I need to implement the move. And you know what? It's going to be almost exactly the same as this part. In fact, I'm just going to copy and paste this part that we've already written down here. Same switch case that we just saw. But now I'm going to change it so that anywhere I see the enemy, I'm going to replace it with the player. And anywhere I see the player, I'm going to replace it with the opponent. And then change these in order to maybe fit a little bit better for the message. But really, it's almost exactly the same code. So no reason to write it all out again. Just copy and paste it and then make the changes that we need to do. So first, calculate the damage. Their attacks do the same damage, so there's nothing special about that. That can stay the same. The opponent is not going to hurt themselves, though. They're going to hurt the player. So change it so that I'm removing the damage from the player's health, not the opponent. But it is the opponent that needs to pay the energy cost. So change that. Oh, did I say them opponent? That doesn't. This means the opponent, which means I made a mistake back up here. Let's fix that. And fix that. There we go. That looks better. Coming back down here. We're not going to do player Pokemon. I'm going to use the opponent. Oh, I should be writing this before that $. The opponent Pokemon. And I'm going to say enemy there. Used the enemy attack. Remember, this is case 1, which is the regular attack. And then, not the opponent, I'm going to say your Pokemon. And then player Pokemon took however much damage. So just changing the strings so that rather than it's the us attacking the opponent, it's the opponent attacking us. That one's all done. Now we're going to take case 2 when they do the special attack. Now I'm going to check if the enemy energy is high enough for them to use this attack. Calculate the damage exactly the same. Remove it from the player's health, not the enemy. They're not going to hurt themselves. Unless if they attack themselves in confusion, I suppose. And then the enemy is going to have to pay that energy cost. Then once again, we're going to change this so that it fits here. And you know what? I'm just going to copy and paste what I did here. Put it there, but change it so that we're using the special attack instead. Because the message is going to be exactly the same. The only difference is here they're using the regular attack, and here they're using the special attack. Oh, did I name this wrong? It says could not find enemy attack. Did I mean capital enemy attack? I should not have named a capital enemy. We should be doing everything in camel case, lower camel case, meaning that the first letter needs to be lowercase. Oh, look at that. I made a mistake. How many of you saw that before I did? Okay, so that's fixed. Go back down to the code that we're looking at. Down here. Okay, so it's not giving me that error there anymore. Looks good. Here we gave the right message. So now we need to fix this so that it's the enemy Pokemon. And I'm also going to say the opponent Pokemon tried to use their special attack, but they didn't have enough energy. So, same thing, just giving a little bit more context so that you don't confuse the opponent Pokemon with their Pokemon. Sure, they're different in this case, but if we give them the opportunity to choose their Pokemon, there is a chance that they are the same Pokemon. Alright, then that's all done, special attacks all fixed. Now we're going to take a look at if the opponent uses rest. So change it so that it's the enemy that gets the energy. Make sure that it's the enemy energy that is capped at 10. And then, once again, give them a message here. Let's say the opponent Pokemon rested and gained 3 energy. There we go. And that's really the end of the opponent's turn. Almost identical to the player. Give them the energy. Find what move they want to do. Don't have to print the game state because it's a computer player. They don't know how to read. Use a switch in order to figure out what move they did and implement it based off of what random number got generated. So, now, down here, this is the end of our if block. This is the end of the switch. This is the end of the if of the computer player's turn. Now, that whatever player got their turn, we need to switch it to the next player, the other player, so that they get their turn next. I'm going to do something a little bit clever here. Because remember, we have something called player turn. That keeps track of whose turn it is. If it's true, it's a player's turn. If it's false, it's an opponent's player's turn. And now I need to switch it. If it's true, I need it to be false. And if it's false, I need it to be true. And what I can do is I can just say that it's not now equal to not the player turn. And this will now automatically change it to the opposite of whatever it currently is. If it was true, it becomes false. If it was false, it becomes true. There are lots of different ways that you can do to keep track of whose turn it is. And this is the way I chose. And so that is most of the game now working. This would be a good place to now test it and see if it's doing what we want it to do. So I'm going to open up the console over here so we can now see it. And everything looks fine. I don't see any red squiggly lines or anything indicating that I have a mistake somewhere. Let's hit play, see if this is working. Oh, there we go. Pokemon Battle, do your best to defeat your opponent. Give us a blank line. Print out the state of the game. I would like this to be a little bit more separated. So maybe I'll put a blank line after the energy here and a blank line here. So let's do that now while we're doing an eye on it. So I want to put a blank line after we say the player's energy. So that's happening right here. Then I want to do another one right there. So that happened right here. And you know what? Maybe I want to have another blank line after this. Sure, why not? So right after rest, I'm going to put another blank line and I'm going to ask them to select or move. Okay. Let's stop that. Check my changes, see if I like them. I like that. That looks a lot cleaner. Chunked up really nicely. Everything looks pretty clear. Alright, I like that. Let's continue on with the game. So let's first try a tackle. Uh-oh. I made a mistake. Reference error is NaN not defined. What is my error? My error is that it is supposed to be a capital N there. Now we see that it shows up. So now it knows what that function is. Okay. Error fixed. How many of you did you saw that error when I was writing the code? Okay, start again. Try to do it again. Alright. Looks pretty good. Pikachu used tackle. The opponent Magikarp took 12 damage. Then the opponent got their turn. They used splash. I took 14 damage. That doesn't sound fair. And now we got a new update on what our hit points are. Notice that they both went down and went down by the correct amount. Mine is 14 lower. Magikarp's is 12 lower. And our energy looks pretty good too. Alright, let's hit him with a big move. Thunderbolt. I did 25 damage, 15 damage. That's really bad. But it is in the range I'm supposed to. They also used a water gun. Did they use water gun last time? It looks like they might be using the same thing. That might be something we need to look at. Make sure they're not using the same attack as me. So, I took 18 damage. And looks like I'm losing. Let's try the rest. Make sure that works. I rested and gained 3 energy. Okay. The opponent didn't use rest. That was something I was concerned about, that maybe they were copying the same thing as I did. That would indicate that maybe I wasn't setting their move correctly, but no, they tried to use water gun again, but they didn't have enough energy, so they didn't do any damage. Pikachu, no damage, but I got a whole lot more energy. Opponent Magikarp, also no change, but didn't have enough energy. Now with all that energy, I'm going to Thunderbolt. Oh, I'm still not doing really great damage. Maybe there's an issue there. Doesn't seem like it. Use water gun, 18 damage, looking good. And we'll just keep on playing until it ends. Oh, big 25 damage. Awesome. Looks like it's being generated in the right range. And looks like I'm winning. Do I have enough for one more attack? Oh, I only have 2 energy. I can't use Thunderbolt. Let's use a regular attack. I did 11 damage. Ooh, I got hit pretty hard, but he's down to 6 hit points. Let's finish him off. One more attack. And the game ends, which is exactly what we wanted to happen. Alright. So, looks pretty good. I want to put some more space between some of these so that it reads a little bit better. So now, let's do that. Down here, I didn't test our input verification. We should do that next time we're testing. But let's just fix this. So I'm going to put an end of line right there. That'll give us a little bit of space after we give that message. We'll do the same thing with all these other ones. Just throwing in a end of line to separate it from what we print next. And then do the same thing with the opponent's moves. Like that, and like that. Oops, that's not quite right. Like that, and like that. So after every message, after a move, we put in a blank line, just like this, just to kind of separate things a little bit better. Um, game ends. Uh, and that seemed to work pretty good. Now let's give a little bit of message about what happened. And then we can also look at allowing them to play again. So, at this point, the game is over. Someone won. We need to check who won so we can give a message. And what I'm going to do is I'm just going to check the player health. See, did they lose? So is this less than or equal to 0? That would indicate that the player lost. And if they did, then I should print out a message saying that they lost. Whoa, what happened? Out of sync? Well, if you ever see this, always do reset to mine. You're only going to ever use this sync to shared if you're doing coding with another person, because you don't want to erase all the stuff that they're doing. But since I'm the only one that's doing this coding, there's no way I can lose anything by just resetting it to what I've written, because that's the only thing that exists. Control log, and now give that error message, or not error message, just a message saying that the player lost. You were defeated. That's not how you spell defeated. And sad face. And then, well, if the player didn't lose, that must mean that the player won. It's the only other option. So I don't need a condition there. I can just do an else and print out a message saying that they won. You won! Or better yet, you were victorious. Happy face. Alright, that looks like it works. Test it out one more time, but there's a couple more things I want to add, as well as notice that we got a lot of text here. Wouldn't it be really nice if we could just kind of erase this stuff and start cleaning every once in a while? I'm going to show you how to do that too. So, but first thing, what we need to do is we need to make it so that it can play again. Now, that means we're going to go back up to that very beginning. Remember where I made those empty lines right at the beginning? That's why I made them for. I know it's going to come back, and I was going to be making a loop here so that it could play again. So, to do that, I need to make a new variable that is going to keep track of whether or not we should be playing the game. I'm going to call it play again. I'm going to set it equal to true, because we want it to at least play once. And then I'll change it to false if they want to quit. And I don't know how many times you want to play. If you don't know how many times you want something to loop, that means you want to use a while loop. And I'm going to say while play again. I could just say while play again is equal to true, but that's kind of irrelevant because it's already true. So I can just say while play again. I'm going to open some brackets. And the reason why I'm doing it here, you might say, couldn't I just start it here at the beginning of the loop? The reason why I'm doing it at this point is because after I play a game, the player health and their energy is going to be different from what it should have started at. So when I want to play a game, I need to reset all of these values back to their original values, that's why I'm doing the while loop here rather than further down below. If I did it farther down below, all these values would be the same as what they ended with at the end of the previous game, and the game would actually probably just end right away because one of the players all start off with 0 or less health. So starting the loop here because I want to reset all those variables. And I want to then put a closing bracket. So I need to close this bracket somewhere. It's currently not closed, giving me a red indicator indicating that there's a problem. And I want to close this at the end of the game, way down here. Alright, and I could hit this button and it would format everything for me, but it's always good practice to do it yourself because once you get into Computer Science 20, you're going to have to do it manually. There will be no auto format button. Python does not allow that. So I'm going to select everything that's inside that loop. I'm going to hit Tab to tab it over, make sure my indentation is right. If you ever want to unindent something, you can hold Shift Tab and it'll go back. So Tab to move everything to the right, Shift Tab to move everything to the left. There we go. But everything's now tabbed over correctly, showing it's inside of this loop. Now down at the end of this game, right here, after this if, I need to now check, do they want to play again? And I could use a prompt for this and check what they enter, but I'm going to use something a little bit different. Some of you might already know this. I'm going to set my play again function, or play again variable. I'm going to use the confirm method. What this does is this will give me a true or false. So I don't actually have to set it to true or false based off of what the input is automatically going to be true or false. They're going to enter a yes for true or an N for false. I'm going to say, do you want to play again? Just like that. We'll shuffle that over so we got a little bit more room here. And that's it. That will now set this to true or false depending on what they enter here. Pretty good. Now, last little thing I want to do is I want to clear the console at the beginning of game and also between each round so I don't have this endless scrolling happening. So at the start of every game, right here, I'm going to clear the screen. The way we do that is we use another console command, but not console log. We're not going to print something out. Instead, we're going to clear the console. That's going to erase everything. So the first time we do this, it does not actually do anything because we haven't printed anything out at that point. But the second time, it will erase everything that happened in the previous game, and we'll start fresh. I also want to clear the console after they choose what move they want to do. So right here, I'm going to do another console clear. And that way, after they enter a move, they'll see what happened during their turn, what happened during the opponent's turn, they'll see what the new status of the game is, and they'll be asked to enter the next move. So let's see what that looks like. So, I'm going to shuffle all this over, press play, make sure everything works, looking pretty good. Select my move. Let's use tackle. Actually, no, let's try our input verification. Let's try some bad input, see what happens. I want to use H. That's not a number. Hey, it's correct. That isn't a number. I want to use the move 100. Oh, that's not a 1, 2, or 3. All right, that looks like it's checking it as well. Sounds good. Looks like our input verification is checking the right mistakes and giving a good message. So let's play fairly now. Let's use our tackle attack. Oh, notice that rather than printing down below, it's now back up here. That's what the console clear did. It erased everything that we saw already and started fresh. So it said Pikachu used tackle. Opponent Magikarp took 13 damage. They rested. New state of the game. Printed it out. Asking what we want to do next. Let's hit him with a Thunderbolt. Pikachu used Thunderbolt. Opponent Magikarp took 20 damage. They splashed us back. Updated to show us what the state of the game is. Can we use Thunderbolt? No, we can't. We didn't have enough energy. And they rested, now they got a whole bunch of energy. But notice that they're capped at 10. Previous time, they had 8 energy already. And then they rested, so they would have had more than 10 energy, but our minimum function looks like it's working, making sure they don't go above 10 energy. Now we got some energy that we can afford to spend, because we still have that 2 at the beginning. Let's hit him with a Thunderbolt now. Awesome. And we'll just maybe spam a tackle a bunch of times until they are defeated. Perfect. End of game. We won. Beat them with tackle. We were victorious. Do we want to play again? Y or no? So let's see if we can play again. Hit Y. Starts all over, right from the beginning. So let's spam attacks now. And see if we can end the game. I should be able to hit end. And the game stops. Perfect. And there we go. Our game now has all the basics. We have, going back to the assignment, we tracked the energy and the hit points, gave them different energy costs. Damage was different for each, but made within a particular range, so we set a minimum and maximum damage and created damage within those ranges. The opponent attacked with a random attack. Game ends once one of them gets down to 0 or less, and when the game was over, we gave them the ability to play another round if they wanted. But it does only have one Pokemon, so it's up to you to now give them a choice on what Pokemon they get to use. I've written our program in a way that this should be not too hard to do because I used abstract variables of player attack and enemy attack rather than specific variables that are connected to Magikarp and Pikachu. So I didn't care what Pokemon they chose, I just wanted to use these abstract variables that track the really important stuff. And you'll need to add some sort of elemental weakness so that they can do bonus damage depending on their types. This is also not too bad to do, but you'll need to do this part first. Okay? So, once again, a reminder. Now that you watch this video, this is going to affect how your grade is going to be marked. If you follow this tutorial and you get all this down and it works, that's developing 1. If you now comment on all this code, and I've been talking about what all this code does the entire time, so you should know what everything does, you can now comment on it and tell me what it all does. That will get you to a developing 2. If you want to get a proficient level, you need to now add, not just comment, but you need to also add these 2 bonus things. So you get one of them done, proficient 1, get both of them done, proficient 2. To get yourself to an exemplary, you need to do all of it. So add the commenting, do both of these bonuses, and then you're going to need to add extra features on top of what we already did, but are not one of these. One of them that you might want to do would be for when the enemy computer player is choosing their attack right here, have it so that they don't choose every attack equally, but instead randomly choose based off of different probabilities. So maybe they might want to use the regular attack more often, they don't rest very often, or maybe they use a special attack quite often whenever they can. So you can make it so that they're a little bit smarter, or at least change the probabilities. That's one idea. Alright, so I'm going to stop there. I hope this helped, and I will see you guys later. Adios.